Hello, dear students. Welcome you all to the Swiflearn. Today we are going to be learning friction. We'll be learning all the important points about friction. Before we go ahead, let me first introduce you to Swiflearn. Well, Swiflearn is 100% live and interactive classes. We have personalized batch of a minimum of 6 students in each batch, and there's a dedicated academic mentor team to track your work progress as a student. And also we cover syllabus as per the school exam schedule, and also we handle custom request as well when if you have any particular topic that you're finding it very difficult to understand, so we have custom request as well. And some of our key features include we provide detailed progress reports. We also provide Swiflearn academic test series, that is SATs, and we take unlimited practice tests and subjective tests to ensure that the student is perfectly thorough with the portions that are taught, and they can easily, score good marks or easily understand all the topics that are taught in school. Yeah, so these are some of the key features of Swiflearn. And before we go ahead, do not forget to like, share, and subscribe to our channel. And also click the bell icon to never miss any update. So moving on to today's portion, that is friction. It is a grade 8 portion, friction, that we are going to be covering today. You have a chapter, you have an entire chapter called as friction. We will be summing up the entire chapter in today's live session. Clear? Also, I will be looking at the comments. So if you have any doubts regarding any thing that I'm teaching today, if you have any doubts, you can send a chat or a comment in the comment box, and I'll definitely answer your doubts. Okay, so with this, let us go ahead to understanding what is friction. Okay, so these are some of the points we will be learning today. We'll be learning what is friction, what is the force of friction, the types of friction, which is static friction and sliding friction. We'll also be learning the factors affecting friction, and also we'll be learning why is friction called as a necessary evil. That is, friction is necessary, yet it is evil. So we will be learning the advantages and disadvantages of friction as well. Yeah, so without any delay, let's begin with friction. Now observe this case. Okay, a person is pushing a car. Now observe this case. The person is pushing the car in the opposite side, right? So in both the cases, okay, when the person is pushing the car, he feels that he feels a force that is applied on the opposite side. That is, you can follow these arrows. See, the person is pushing this side. That means what? Which is the direction of applied force in the case one? This side, right? This side is the direction of the applied force. Whereas there is a force that is acting on the opposite side. So always, whenever there is an applied force, there is another force that always acts in the opposite direction of the applied force, right? And this force is called as the frictional force. I repeat once again. Now, whenever there is an applied force, okay, like kicking a ball or anything, whenever there is an applied force, there is another force which acts opposite to the direction of applied force. Make a note of it. Frictional force always acts on the opposite direction of the applied force. Clear? Now imagine you are kicking a ball. Okay, it's the best example to understand friction. Imagine there's a ball, you are in this big ground, okay, and you are kicking a ball. The ball starts rolling in the side of which you're kicking, right? So which is the applied force? The kick, the direction of applied force is the direction to which you have kicked the ball. Okay, now from there the ball starts rolling, it keeps on rolling. Afterwards, what happens to the ball? It stops. On its own, it stops, right? Even if you do not stop a ball, after a while, the ball roll, and gradually it stops. How is it stopping? Is it any magic that is happening? Unless and until a force is applied, it cannot change its state of motion, right? Then how is it stopping? It is stopping because of frictional force. Now, in this case, which is the frictional force? Where is the frictional force? The frictional force is acting on the opposite side. Okay, if the ball is rolling this side, the frictional force is acting on the opposite side, and it is acting between the ball and the ground. Okay, the frictional force is acting between the ball and the ground. Clear? So frictional force is basically a contact force. Now forces, there are two types of forces, okay? There is contact and non-contact force. Contact force means two objects, when they apply force on each other, it should be in contact with each other. Example, frictional force. Frictional force will only work when the object is contact with the other force, other surface. Then only frictional force will be applied. Okay, now non-contact force that do not require any contact. For example, you have gravity. Gravity, it's not necessary that it has to pull only when you're in contact with the center of the earth, right? Gravity is basically the force that pulls you down to the earth, right? So now that you're clear with the concept of contact force and non-contact force, frictional force is a contact force. Clear? That is, both the object should be in contact with each other. Then only frictional force can be applied. So now let us look at the definition of frictional force. Okay, the opposing force that is acting in these two cases are called as frictional force. Okay, now if the force is applied from left to right, then frictional force will be applied along the right. Or if the force applied or the applied force is from the right, then frictional force will be from the left. Okay, that means whichever direction is your applied force, frictional force will always be opposite to that direction. Clear? Moving ahead, any doubts regarding the topic, you can send me in the comment section. I will go through that and I'll answer. I'll read through and answer, okay? Any doubts that you have. Now, moving on to the force of friction, let's just understand force of friction a little more better. Now, the force of friction is a force that always opposes the applied force. So whenever there is an applied force, like this boy or this man over here, he is applying force to this wooden block, right? To this wooden box, he is applying force. Now, frictional force will always be opposite to it. Clear? I hope this much is clear. Moving ahead, now this is the example that I gave you earlier. Now the speed of the ball slows down. After you kick it, it starts rolling. After some time, the speed of the ball slowly slows down and gradually it will come to rest. Why does this happen? This happens because of friction, as it is an opposing force. Moving ahead. Okay. Now, a vehicle slows down when brakes are applied. Not only vehicles, any object moving over the surface of another slows down. Okay, whether it's a vehicle, whether it's a ball or any surface, whenever it is rolling over another surface, at some point it will stop. Why? Because of frictional force. Now, the force of friction is an opposing force that acts between the two surfaces in contact. Now, take the case of this wooden box. Okay, this wooden box is placed on this floor. Okay, now a person here is pushing this wooden block. So this is the direction of the applied force. Okay, now a frictional force always acts opposite to the applied force. Yes or no? So frictional force will be here in the opposite direction. And towards the center, obviously, you have the gravity. Now, why is friction happening? It is because it happens between the surface of two objects in contact. Okay. Now, imagine you're walking on the road and there is a banana peel on the road which you have not seen, and you by mistake step on it. What happens? You will skid and fall down. Yes or no? Or now imagine another scenario wherein you're walking on a wet floor. Okay, it's more difficult to walk on a wet floor. There are chances that you might slip and fall down. Yes or no? Why is this happening? Because in that cases, the friction is more between the surface and the ground. Okay, so now imagine Okay, so now moving ahead, have you ever wondered why is it easier to drag an object on a smooth surface as compared to a rough surface? Now imagine there is a surface which is very smooth, like a marble floor or something. Okay, it's very smooth. And there is another surface which is rough. That is, it has a lot of stones and rocks and it is rough. Now, if I'm telling you to push a substance, an object on these two floors, which one will be easier for you? It will be easier for you people to push on the rough surface. Yes or no? It will be more difficult for you people to push on the rough surface, and it will be a lot more easier for you people to push on the smooth surface. Yeah. So now, as we all know that the force of friction acts between two surfaces in contact. Thus, in all these cases that we discussed, that is, the first case was when we slipped in a banana peel. The second case was walking on a wet floor. The third case is pushing on a rough surface and pushing on a smooth surface. Right? In all these examples, in all these cases of friction, it shows that friction is not the same in all the surface, right? Friction changes, right, based on the surface, based on the material, whether it is wet, whether it is dry. Based on the surface, frictional force changes. Yeah. Now, so what are the factors affecting friction? The next question that arises in your mind is, what are the factors that are affecting friction? Well, friction depends basically on two factors. Okay. Number one, the nature of the surface in contact. Okay. And number two, how hard the surface are pressed together. Okay. First one is nature, right? For example, if it is jute cloth or if it is a smooth marble floor, which one will be difficult? Which one is rough? Jute cloth is rougher than marble floor. Yes or no? So marble floor is smoother than jute cloth. So the friction is lesser in a marble floor as compared to a jute cloth. Okay. Now, another factor that friction depends on is how hard the surface are pressed to each other. That means now this is the surface and this is the object. Now, how much hardness is this object pressed to the surface also affects the friction. How? Now, if it is pressed harder, friction is more. If it is pressed softly, friction is less. Getting it? Now, moving ahead, take an object. We are going to do a small activity. Okay? Now, take an object. Okay, now take an object object. Now friction, the activity which we are going to learn today is friction depends on the nature of substance, right? Or the surface in contact, what kind of the nature, like whether it's a marble, whether it's jute, whether it's rough, whether it's smooth, right? So based on the nature of the surface, friction depends. Now how can we see that? Let us do a small activity to understand that friction depends on the nature of the surface in contact. Okay. Okay, for the activity, first you're taking an object. Okay, is there any doubts till here? Please send me in the chat box if you have any doubts. Any doubts regarding the topic, please send me a message in the comment section. Till here, if you have any doubt, I will wait for a minute's time to see if you have any doubt, and then we will go ahead with the activity. Okay?